To write the equation of a line would be to write it in point-slope form. Point-slope form, if you recall, looks something like this. It says that the equation of a line should be given by if m is the slope and x1, y1 is a point on the line, then this formula will tell us the equation of our line. Y minus y1 is equal to the slope times x minus x1. If I want to write the equation of this line, I can use this point-slope form. I know that I have a point. This is going to be my x1 and my y1. And I know the slope. So in point-slope form, so the point-slope form of this line would be y minus 2 is equal to negative 1/3 times x minus 0. Would be the point-slope form of this line. Now that's just the basis. Now point-slope's not a form we're going to leave a line in. What we're going to end up leaving it is either standard form or probably better yet slope-intercept form, mx plus b form. So we're going to use distributive property and rewrite this so we have our line in y equals form. Might be a little bit easier to graph. So I'll clean this up. X minus 0 is just x. So we have y minus 2 equals negative 1/3 of x. And therefore the equation of this line would probably be y equals negative 1/3 of x plus 2. Y minus negative 1 is equal to negative 1/2 of x minus 8. Minus the negative 1 is y plus 1. Minus y1. If y1's negative, I'm going to subtract a negative, which is plus a positive. And I'll distribute this negative 1/2, and I'll end up with this. Y plus 1 is equal to negative 1/2 of x plus 4. Subtract 1. And the slope-intercept form of this line would be negative 1/2 of x plus 3. We know that that point, negative 2 comma 1 is on our line, and then what's the slope of our line that's parallel to this one? Then the slope is the same. So we know for part A that this is the information that's important. And then for part B, to find a line that's perpendicular to this one through this point, what's important information? Same point, and the slope is now the opposite reciprocal of this line. So then what's the slope of our perpendicular line? 1/3. Oh man, how about instead of I tell you the slope, I give you just 2 points? How are we going to write the equation of this line? What could we do? Holy cow, Wesley, what could we do?
Do y2 minus y1 over x2
Oh! Also, if you found the slope, and you chose either one of those 2 points as your second point, then you have the right information for the point-slope form of a line. Absolutely. Find the slope, get a number. Then use one of the 2 points, either one, it don't matter. You'll get the same equation of a line when you simplify your equation. Okay. Negative 5/2 times positive 6 is, see, half of 6 is 3. 3 times 5 is negative 15. And then we'll add 15 to both sides, and you end up with the equation y equals negative 5/2 of x. Should have a y-intercept of 0.
Not banished.
Okay. Is our final answer. A point here could be, a time would be at 1 minute, we're at negative 5 degrees. Then what would be another point that we could get? Because claim you can get a second one. Nate? 6 minutes in, you're at 20 degrees Fahrenheit. With those 2 points, I claim now this problem is identical to those basic example ones we did in the front side. You could find the slope using these points. 20 minus negative 5, 6 minus 1. 20 minus negative 5 is 30 over 5. Sorry, it's 25 over 5, where the slope is 5. So if the slope's 5, you can pick one of these 2 points and write the equation of our line in point-slope form. Okay? I'll leave that for you to do on your own. In particular, a direct variation equation is any linear equation of the form y equals a times x, where a is called the constant of variation, equal to 3 in this case. So if a is equal to 3, then what would be the equation of this direct variation line? Y equals 3x. The equation of the line needs to be y equals 3x. Take your point, use it to find the constant, and then rewrite your equation with the number that's the constant. Constant of variation is a. It's also the slope of the line. Well, if you think of this as if you think of this as a line of, if this is like, so b is 0, and that means these 2 things have to match up. So yeah, the constant of variation is just the fancy name we give the slope of a direct variation.
Why are we changing it?
Because it has a special name, the constant of variation. If it's direct variation, it's got a special name. So we'll give it a special letter. Check if you haven't done it already. We should have y equals a times x. Therefore, a is negative 1/3. Therefore, our equation is y equals negative 1/3 x. Would be a direct variation equation through that point. Okay. We have a Hooke's law thing here. I'm going to skip over Hooke's law. Even though it pains me, I'm a physics teacher as well, and it's a physics thing. I'm going to skip over it. We'll come back to it maybe at a later day. But it's a very simple. It's a very simple application of direct variation. You might see it there, yeah. It's a quick story problem. It says it varies directly. So it tells you the force. It tells you the distance at which it stretches, and it says it's varied directly. So if it's varied directly, you know that they have to be related by that same law. So you could say, I guess we'll just do it then, huh? The distance varies directly with the force. And if I tell you the distance and the force at which you pull, then you can find the constant of variation. And then you could get an equation. Then if you know that, then you know the constant and you know, say, a force, you could find the distance, from there. But if you have your skeleton guy there, then you could say distance is 15, excuse me. So you have 15 equals the constant times 9. Then you could use that to find your constant. You get an equation. You end up with d equals 15 over 9, which is 5/3 of the force. 15 over 9 reduces to 5 over 3. And then using this, and you know that you applied a force of 6 pounds, then you can do 15/3 times 6 will give you the distance it stretches. Okay. The last one I think is probably the easiest one. The last one gives you a table of values, and I just say, is it direct variation or not? What sort of pattern should the direct variation fall into? What's the equation direct variation? Y equals ax. So that means that if this data is directly varying, then that means that this A should always be the same. So how can we solve for A really quickly? This varies directly. Does it show direct variation? If it does, it should fit this form, which means that this constant of variation better be the same for every piece of data. And you can find the constant of variation for every piece of data by dividing y by x. So if we divide y by x in every single piece of data, we should get the same constant of variation if it varies directly. Do we get that in this case?
No.
You get 24 over 1. The first one you get A is 24. Second one you get A is 6. Oh, we're already done. Different constants of variation, not varying directly.